In this session, we're going to take a look at simplifying quadratic expressions. In a previous video, we looked at simplifying linear algebraic expressions. Now, the methods are going to be similar with just a few twists, just because this is a quadratic expression. Now, let's dig in. Let's start off with something pretty simple, just so you can see that the method works regardless of whether you're dealing with a linear or quadratic. That's one of the beautiful things about math. Once you understand the principle behind the method, you can apply it to a varied set of examples. So we're going to look at quadratic expression. So we have 4x squared plus 3x squared plus 2x plus 5. Like I showed you in the linear expressions, the first thing we're going to do is group common terms. So we can see here that x squared, and these are common terms right here. So 4 plus 3 is going to be 7, and then we have 7x squared, and then we have 2x and 5. So the principle works. Now let's look at some other examples. As I typically like to do, as I always like to do, I want to start with something very direct, and then we'll try to vary the complexity and the difficulty as we proceed. Let's look at some other examples. 4x squared plus 3y squared plus 6x cubed plus 4x squared plus 5y. So we're going to group common terms together. So we have 4x squared plus 4x squared plus 3y squared plus 5y plus 6x cubed. Ideally, this shouldn't be there because it's a trinomial, so it shouldn't really be there. So 4x squared plus 4x squared gives us 8x squared. We have 3y squared, no common terms to it, and then we have 5y, and then of course 6x cubed. But I'm going to ignore this because it's not a quadratic. It's not part of the quadratic expression. Now let's look at some other examples. Let's look at an example like 4x x plus y plus 3x squared plus y squared minus 5x. Okay. We're going to apply the distribution property to these two expressions here, this set of expressions. So that's going to give us 4x multiplied by x plus 4x multiplied by y plus 3 multiplied by 3x squared plus 3 multiplied by y squared minus 5x. So now we'll simplify this so we can have the expression we're going to work with. So 4x multiplied by x gives us 4x squared. 4x multiplied by y gives us 4xy. 3 multiplied by 3x squared, 9x squared. This is going to give us 3 times y squared gives us 3y squared, and then minus 5x. Now we're going to group common terms. What are our common terms? So 4x squared, the common term is 9x squared plus 4xy, no other common term to it, plus 3y squared minus 5x. So here we're going to simplify the common terms we've grouped. 4x squared plus 9x squared gives us 13x squared. Now we have 4xy, 3y squared, and then minus 5x. So you can see that the principle works regardless of whether you're dealing with a polynomial, a linear, a quadratic, regardless of what you're dealing with, the principle always works. Group like terms together and then solve the like terms. Now I think this should give you an idea of how this principle would work. So I mean, we could do one more example just to show you that regardless of how complex your expression is, if you follow the method, you would always get to the right answer. So let's try one more. 7x x plus 3 plus 4x 2 plus x minus 5 x squared minus 3. Okay, so we're going to, of course, we're going to first apply the property of addition, the distributive property. So that gives us 7x multiplied by x plus 7x multiplied by 3 plus 4x multiplied by 2 plus 4x multiplied by x minus 5 multiplied by x squared minus 5 multiplied by minus 3. So 7x multiplied by x gives us 7x squared. 7x multiplied by 3 gives us 21x. 4x multiplied by 2 gives us 8x. 4x multiplied by x gives us 4x squared. Minus 5 multiplied by x squared gives us minus 5x squared. Minus 5 multiplied by minus 3 gives us positive 15. So we are going to group like terms. So we have 7x squared. Here's another like term. Here's another like term. Plus 4x squared minus 5x squared. Now we go to 21x plus 21x. We have another common term plus 8x, and then we have 15. So now we have applied the property of addition to this, the distribution property of addition to this expression here. And now we have also grouped common terms, or some would say collected like terms, to this expression, and now we have to simplify. So 7x squared plus 4x squared, that gives us 11x squared, minus 5, that gives us 6x squared. Now 21x plus 8x gives us 29x, and then positive 15. So this is really it. There's really nothing else to add to the process of simplifying expressions. I've shown you that what works for linear also works for quadratic. And if we decide to go to polynomial, and that would be x to the third power, x to the fourth power, x to the 100th power, once you understand these principles, it would work all the time.